So in example 2 here, we have a flagpole that's casting a shadow that's 25 meters long, and this 25-meter length shadow is happening when the angle of depression from the sun is 40 degrees. And so we're asked to solve for the height of the flagpole. And so I've done a little sketch here. And so here's my shadow on the ground, which has a length of 25 meters. And it says that the angle of depression is 40 degrees. And so my line of sight here that I'm going to be drawing is from the tip top of this of the flagpole all the way down to the tip of the shadow. And so my angle of depression is, remember, between the line of sight and the horizontal. And so my angle of depression is actually here. This is actually my 40-degree angle. Okay, and that means that this angle within the right triangle is going to be 50 degrees because those two angles need to sum to 90 degrees. And so now I'm able to say that, and again, I want the height of the flagpole, so I'm going to label that x. So I have the opposite side length, and I want to learn the adjacent side length, so I'm going to be using tan. So tan of 50 degrees is equal to 25 meters over x. And so that means that x would be 25 meters divided by tan 50. And that should turn out to being about 21.0 meters when I round to one decimal place. Okay, and again, as I mentioned in the previous video, if I look from the perspective of the shadow looking up to the top of the flagpole, it actually has an angle of elevation, and that angle of elevation is actually going to be 40 degrees, and that should make sense as well, because I know the sum of all the angles in the triangle need to add up to 180. And so I could also solve this by using that angle, and I would say that tan 40 degrees should be equal to x over 25. So x should be 25 times tan 40, which should get us to the same answer.